students, welcome to my YouTube channel. In this video lecture, we are going to continue solving the next 10 questions from Great Circles chapter in Keith Williams' General Navigation book. So let's begin with question number 81. The automatic flight control system in aircraft is coupled to the guidance outputs from an inertial navigation system. The aircraft is flying between inserted waypoints. So there are two waypoints that you have input. 65° north, 20° west, 65° north, 30° west. That means both positions are located on the same latitude but different longitudes. With desired track selected on the control display unit to the nearest whole degree. What is the initial track readout from waypoint? So what is the initial track readout? Initial track at the point of departure. So let's plot this 65 north. So let's say this is your Earth representation. This is your prime meridian 0°. Okay, 20 west and 30 west. This is 20 west. This is 30 west. And both are located at same latitude 60° north. Okay. So 65 north. 65-20 west is point A. This is point B. Now we are in the northern hemisphere. So the great circle track will pass through the nearest north pole like this. Okay. So this will be your great circle track. This will be your Rumline track. Okay. So we have to find our track, initial track readout. So we are flying from waypoint number 3 towards waypoint number 4. So great circle track at A. Now, so great circle track at A. So flying from A to B, you will be flying a Rumline track of 270 of westerly direction, correct? So I'm going to write here Rumline track at A is 270. So great circle track at A will be what? It will be Rumline track at A plus convergency angle. Okay. What is convergency angle? This is the convergency angle, the angle between great circle track and Rumline track. So this great circle is nothing but made up of two factors or two things, this Rumline and additional this convergency angle. So that's why we will add that. Now we know Rumline track. Let's find convergency angle. What is convergency here? D long in degree into sine latitude. So D long is 20 west, 30 west means 10°. Sine latitude is sine 65. So sine 65 into 10 is 9° 3 minutes or approximately 9°. So convergency angle will be half of convergency. So half of 9°, that is 4.5 degrees. So 270 Rumline track plus convergency angle 4.5. So great circle track will be 274.5. So you will select that option which has the value which is closest to this one, 274 or 275. Aeroplane flies from 59 south 140 west to 61 south 149 west. TAS is 480. Autopilot is engaged and coupled with INS, in which track AB is active. On route AB, what is the true track? Okay, so again we have to find Rumline track, great circle track at A. So now we are in the south hemisphere. Okay. So this is your prime meridian, let's say 0°. 59 south and 61 south. So 59 south, 140 west, and 61 south, 149 west. Okay, so you are in the southern hemisphere, so the great circle track will pass to the nearest south pole like this. Okay, so this is your point A, this is your point B. Now we have to find great circle track from A to B. Now in order to find great circle track A to B, we will have to follow a particular method. It's little bit long, so I'll show you. Now what you do is draw this meridian like this passing through Bravo and Alpha. Then join this. Now this latitude will be 59 degrees south latitude, and this latitude is what latitude? This is 61 south latitude, correct? So I want you to find this distance, which is your departure distance between meridian 140 west and 149 west. Then second step, I want you to find the great circle distance between latitude 59 south and 61 south. So we will have this triangle, and we will come to know the two sides of that triangle. When we know the two sides of that triangle, we can calculate this angle using tan theta. Okay, so let's do it. Step 1, rhumb line distance is d long in minutes to cos lat. Okay, so what is the d long here? 140 west and 149 west. So 9 degree into 60 into cos of latitude. So latitude is 59 degrees south. So cos 59. So cos 59 into 9 into 60 is 278 nautical miles. Next, great circle distance. Difference between two latitudes in degree multiplied by 60. So the difference between 59 south and 61 south is 2 degrees into 60. So 2 6 are 12. 120 miles. So we have this triangle whose two sides are 278 and 120. Let's apply tan theta formula to find out this particular angle. So tan theta, that particular angle, is opposite upon adjacent. Now what is the side opposite to that angle? That is 120. And adjacent side is 278. So 120, 278, 0.43 something. So theta will be tan inverse 0.43. So shift tan inverse that is equal to 23 degree 20 minutes, or let's consider 23 degree. So this angle is 23 degrees. Okay. Now next step, rhumb line track at A. Now I'm going to erase these two things, this line and this line. Okay, I'll just skip this one. Now this is your rhumb line track. This purple line is your rhumb line track A to B, correct? This is your rhumb line track. Now the rhumb line track from A to B is nothing but this much, only up to this value, correct? This value. So how to find that value? You will have to subtract 270 minus 23. Why 270 minus 23? See, this complete angle will be 270 degree. Going from A to that side, that direction is 270. From that big 270 angle, that big angle, you are going to subtract the small 23 degree angle. When you do that, you will be left with only this particular rhumb line track, only up to this much. You will be left with this much angle, and that is nothing but your rhumb line track. So rhumb line track is 270 minus 23, 247. Okay, now that you know rhumb line track, we can calculate great circle track. Great circle track at A is again rhumb line track at A minus convergence angle. This is the convergency angle between them. This is your rhumb track. This is your great circle track. So great circle is below the rhumb track. That's why you have to subtract it. Now what is convergency angle? Convergency is d long 9 degree into sine lat. Sine average is sine 60. So sine 60 into 9 is 7 degree 47 minutes or approximately 8 degree. So convergency angle will be half of that 4 degree. So rhumb track at A 247 minus 4 degree is 243 degree. So great circle track at A is 24 degree. Simple. Okay, next. Automatic flight control system is coupled to the guidance outputs from an INS system. Which pair of latitudes will give the greatest difference between initial track readout and the average track? In each case, a difference of longitude is 10 degree. Now, initial track means they are talking about your great circle track, and the average track means they are talking about average of great circle is nothing but rhumb track. So we have to find the convergency angle between great circle and rhumb. Okay, so the convergency angle. The convergency angle is nothing but half of convergency. What is convergency? Convergency is d long in degree into sine latitude. That means convergency is proportional to sine latitude. Okay, so we will apply this formula to each of these options and we will check which option gives the maximum or the biggest value of the biggest angular difference. 35 south, 35 north. Now this is inapplicable because both points must be in the same hemisphere. 30 south, 25 south. Okay. So d long, what is the formula? D long in degree into sine of latitude, correct? Now d long is 10 degree as given in the question into sine of latitude. So 30 and 25. The average is sine of 27.5. So sine 27.5 into 10 is 4 degree 37 minutes. Okay. Next 60 north and 60 north. So again here d long in degree into sine of latitude. So 10 degree into sine of 60. So sine 60 into 10 is equal to 8 degree 39 minutes. Next option delta 65 north and 65 north. So d long in degree into sine lat. So 10 into sine 65. That is 9 degree 3 minutes. So the biggest value here is 9 degree 3 minutes. So the answer, which pair of latitudes will give the greatest difference between initial track readout and the average track is option delta. The pair of latitude 65 degree north, 65 degree north. Next, position A is 58 north, 30 west. Position B 51 north and 20 west. What is the rhumb bearing from A to B if the great circle track is 100? So A is T8 north. So let's say this is your diagram. Position A is here. Position B is here. 58 north, 30 west. 51 north, 20 west. Okay. Now let's join that. We are in the north hemisphere, so great circle track will be something like this. This will be your great circle, this will be your rhumb line. Now great circle track as given in the question is 100. This is your great circle, 100. Rhumb line track is this bigger angle. Now this rhumb line track is made up of two parts. It is made up of great circle, the small angle as I have drawn there, plus the convergency angle between them. Okay, so great circle is 100. Convergency angle. Find convergency. Convergency is d long, which is 10 degree, into sine lat. So 51 and 58. 51 plus 58 divided by 2, 54.5. So sine 54.5 into 10 is 8 degree 8 minutes, or approximately 8 degrees. So convergency angle will be half, 4 degrees. So 100 plus 4 is 104. So Ramline track at A. What is Ramline bearing A to B? Ramline bearing A to B is 104. 85. The automatic flight control system in aircraft is coupled to the guidance outputs from an INS. Aircraft is flying from waypoint 1, waypoint 2 towards waypoint 3. Comparing the initial track and the final track, what is the difference between them? So we have to find the difference between great circle track at A and great circle track at B. Now the difference between two great circle tracks, the difference between two great circle tracks by definition is convergency. So let's find convergency. Convergency equals to d long in degrees into sine of latitude. So d long 70 west, 80 west, 10 degree into sine of latitude 70. So sine 70 into 10 is 9 degree 23 minutes, or approximately 9 degree, let's say. Now this is going to be the difference between your great circle track at A and great circle track at B. Step number 2, whether this difference will be increasing one or decreasing one. So for that we will have to understand our DIID diagram. If you are in the north hemisphere, if you are in the north hemisphere, this is your equator, and you are traveling east, and you're traveling west. Now, if you're traveling, you're in the north hemisphere, condition number 1. Condition number 2, you're traveling eastwards. In that case, the great circle direction will increase as you go from point A to point B. If you are in the north hemisphere and you travel westwards 270, the great circle direction will decrease as from point A to point B. Next, if you are in the south hemisphere, and two possibilities, traveling east, traveling west. Now, if you travel east, being in the south hemisphere, the great circle direction change will decrease. And if you travel west, the change will increase. So this is your DIID. Now let's understand the positions given in the question. Where are they? 70 south, 70 west. So both are located at same latitude. 70 south. 70 south, 70 west, and 80 west. So this is the 70 west, this is your 80 west. So you're going from 70 west to 80 west. So you're going from point A here to point B. The great circle track will be like this. So you're going from A to B. That means you're going in the direction of, you're flying in the direction of west, right? And you are in the southern hemisphere. So when you are in the southern hemisphere and you fly westerly direction, the great circle track increases. So your final answer will be, the difference between them is what? So the difference between them will be 9 degree increase. 9 degree increase. Next, 86. Aircraft travels from A to B, 65 south, 10 west, 65 south, 20 west. The true course of aircraft at arrival at B destination. So let's draw this. Both are located at same latitude, 65 south. Traveling from 10 west and 20 west. This is your great circle track. This is your line track. Okay. Now let's find out. Now you're traveling from A to B. Now Rumline track at A is 270. Rumline track at A is 270. You're going directly from A to B, so westerly direction. Rumline track at B will be 090, reciprocal. Next, Great Circle track at A is Rumline track at A minus convergency angle. Why minus? Because this is your Great Circle track, only up to this point. So you will have to subtract the convergency angle from this big Rumline angle. So you are going to subtract 270 minus convergency angle. Convergency here is 10 degree into sine 65. Sine 65 into 10, 9 degree 3 minutes. So convergency angle equals to 4.5. 270 minus 4.5, that is equal to 265.5. Okay, next we have to find Great Circle track at B. Now Great Circle track at B will be Great Circle track at A plus convergency. Why? This DIID formula. The difference between two great circle tracks is your convergency. So if they have told us or if they have asked us to find the course of arrival at B, that means what do they mean? We will take off from point A. The direction of our track will be 265.5 or approximately 265. As we travel towards B, the direction of our track will continuously change as we go towards B, because great circle track involves a change in direction. Rumline tracks have a constant direction. So finally when we arrive at B, our track direction will be much different from the track direction that was at point A, departure. So we have to find that final track direction. Okay, so to find that direction, we will have to add convergency. Why add? Because we are in the south hemisphere and we are traveling westerly. So our great circle track at destination will increase. Okay, so great circle track at A is 265.5. Our convergency is 9. So 265.5 plus 9 is 274.5. So this is your answer. So what is the track course at B? So it is 274.5. Now if they had asked us to find out great circle track from B towards A, then what we would have done is this. We know the Rumline track at B, yes, which is 090. So great circle track at B will be Rumline track at B plus the convergency angle between them. So that is 090 plus 4, 094. Okay, so there is a difference between great circle track B to A, and there is and great circle track at B, just the B. Great circle track at B only means the track direction which is going to change as you depart from A, and great circle track B to A involves B towards A. So don't get confused. 87. The following points are entered into INS. Waypoint 1, 2, 3. You are flying from waypoint 1 towards waypoint 2 towards waypoint 3. What will happen to your track when you pass waypoint number 2? So all the positions are at same latitude, 70° north. Okay, 70° north. First, 50° west. So this is 50 west, let's say. Second waypoint, 40 west, 30 west. Okay, and now you are in the north hemisphere. So your great circle track will be like this. Waypoint 1 to waypoint number 3. Now what happens? When you travel, let's say you're traveling from waypoint 1 towards waypoint 2. A, B and C. Now Great circle track at A will be what? Great circle track at A will be rhumb track at A minus convergency angle. This is your great circle track, this is your rhumb track. This is the convergency angle between them. So great circle will be only this much. So it is nothing but this big rhumb track minus this small convergency angle. So rhumb track at A is 0, 9 or 0. You're going from A to B in the easterly direction. Convergency angle is what? Now what is convergency here? Convergency is 10 degree into sine 70. It's 9 degree 23 minutes or approximately 9 degree. So convergency angle will be half of 9, that is 4.5 degrees. Okay. So convergency angle is 0, 9 or 0 minus, let's consider 4. So 0, 9 or 0 minus 4 is 0.86. Great circle track at B will be great circle track at A minus convergency. Why minus? Because the difference between two great circle tracks is equal to convergency. Okay, the difference between two great circle tracks is convergency. And we are in the north hemisphere and we are traveling east. So in that case, our great circle track should increase. Okay, so you are going to add this. So great circle track at A is 0.86. Convergency is what? Convergency is 9. Convergency angle is 4. So don't confuse. So this is equal to 0, 9 or 5. Next, great circle track at C will be great circle track at B plus convergency. Again, you are in the north and you are traveling east. So 0, 9 or 5 plus 9 is 104. So 086, 095, 104. The change that is happening at great circle track at B is equal to minus 9 degree. Okay, 95 is less than 104 by minus 9 degree. So the answer here is the track change when passing waypoint 2 will be approximately minus 9 degree. What is a rhumb line? Line on the earth which cuts all meridians at the same angle. The vertex of a conformal projection. Shortest distance between any 2 points. A straight line on a Lambert's chart. So it is alpha. Waypoint 1 75 south 30 west. Waypoint 2 75 south 20 west. What will be the approximate latitude shown on the display unit of an inertial navigation system at longitude 25 west? So we have solved similar questions many times before. So let's draw this diagram. Draw two meridians. We are in the south hemisphere. So 75 south, 30 west, 20 west, and another meridian is right in between them. So this is that meridian 25 west. This is your great circle. Since it's the south hemisphere, the great circle will pass to the nearest south pole. Okay. Now, next step, you will have to draw a triangle. We have to find the latitude. We know this latitude 75 south. We have to find the latitude at this place where the great circle reaches its peak position, top position. So, draw this triangle. Now, let's label this. Now, this thing is your departure, rhumb line distance between the meridians 30 west and 20 west. Now, half of that will be here. Half of that departure will be this side of the triangle. This will be your great circle distance, and this angle will be equal to half of convergency angle. Okay. Step 1. Departure or rhumb line distance equals to d long in minutes into cos lat. What is D long? 30 west, 20 west, so 10 degree into 60 into cos of 75. So Ramline distance will be 10 into 60 into cos 75. So 155 nautical miles. The half of Ramline distance will be 155 ka half, 77.6, or let's say 78 nautical miles. So this side of the triangle is equal to 78 nautical miles. Convergency angle. What is convergency here? D long in degrees into sine of latitude. So 10 degree into sine of 75, that is equal to 9 degree 39 minutes, or approximately 10 degree. So convergency angle will be half of convergency. So 10 by 2, 5 degrees. Half of convergency angle will be again 5 by 2, so 2.5 degrees. So the angle inside the triangle is equal to 2.5 degrees. Next, this great circle distance will be equal to how much? Now let's apply tan theta formula. Tan of 2.5 is equal to opposite side great circle distance divided by adjacent side 78 nautical miles. So great circle distance will be equal to 78 multiplied by tan of 2.5. So tan 2.5 into 78 is 3.4 nautical miles, or let's say 3 nautical miles. Now we all know that by definition 1 minute of latitude is equal to 1 nautical mile. So 3 nautical mile will be equal to 3 minutes of latitude. So what will be this latitude? This latitude will be 75 degrees south plus this extra 3 minutes. So it will be 75 degree 3 minutes south latitude. Okay. Next, in order to fly from position A 10 degree north 30 degree west to a position which is 30 degree north 50 degree west, maintaining a constant true course, you will have to fly a Ramline track, drift route, great circle, a straight line on a Lambert's chart. So you will have to fly a Ramline track, right? By definition, a Ramline track is that track or course which has a constant same direction. So a Ramline track. This concludes our lecture. I hope you have understood all the 10 questions I have solved in this video lecture. If you have any questions, let me know in the comment box. Thank you for your time.